noon on KLM Flight 867 and there are 240 passengers on board.
KLM 867 Heavy. We see a black cloud outside, but there's nothing on our radar.
Do you smell something? It's smoky in here. Good thing I have a mask.
KLM 867 Heavy. Deviation to flight plan left.
KLM 867 Heavy. Roger. Left at your discretion.
Look, the engines are on fire. Mayday, mayday, KLM 867 Heavy. We have a flame on all 4 engines. Request pre-emergency vehicles.
This is a true story about an airplane that flew through the ash cloud at Mount Redoubt, Alaska. Luckily, no one got hurt.
As you can see, the number of airports and airplanes impacted by volcanic ash is increasing.
This is a working model of a jet engine. When ash enters the fan blades and the compressor, it erodes the leading edges. When it enters the combustion chamber, it melts and clogs the fuel nozzle. It also clogs air holes in the turbine meant to keep the engine from overheating. When all of this happens, the engine overheats and shuts down.
The main problems airlines face is that there are no onboard ash detectors. Ground and satellite-based alerts are delayed. As you can see here, although Montserrat's volcano erupted at 3 p.m., the pilots received the alert only at 5:30.
We learned from an ash modeling expert that it is very difficult to model ash accurately. Therefore, airlines have only 2 choices when faced with an ash cloud: close all airspace or divert planes. When the Iceland volcano erupted in 2010 and all airspace was closed, it cost the aviation industry over $2 billion. U.S. Air Flight Dispatch sent us this example of an airplane being diverted from Mount Popo, Mexico in July. Airplane diversions can cost $200,000 each. Our goal is to find a way to detect ash on board and communicate eruption information more quickly.
To come up with our solution, we had to consider cost, size, weight, and even FAA approval. As you can see here, we found many systems that could be used to detect ash, but most were too heavy, expensive, or would not work well on an airplane. For instance, we learned from a national park ranger and a geologist that COSPEC is a sulfur dioxide sensor used in the Hawaii Volcanoes National Park. The problem is that COSPEC costs $10,000 and only works at certain angles.
Part of our solution is to add SO2 sensors to 4 air intake locations on the airplane. SO2 detectors are very sensitive, and SO2 is a good proxy for volcanic ash. Each sensor costs $300, making it an affordable alternative to many other solutions. The second part of our solution is to use pilot reports, currently used only to report turbulence, to include SO2. Once filed, these reports are available immediate to all planes. Based on feedback from our 2 presentations at U.S. Airways Operations and U.S. Airways Power Plant Engineering, we changed our solution from ash detectors to SO2 detectors and added pilot reports, and also realized that we needed redundant sensors.
There's an ash cloud outside. Use the force, Anakin.
I don't need to. I have SO2 sensors. Obi-Wan, sulfur dioxide has been detected. There's the ash cloud. I'm filing a pilot report.
R2, Anakin filed a pilot report. We need to change your flight path.